We've been looking at statements from a computational point of view, and that's going to help us with a new concept called logically equivalent statements. So we're going to define first what it means for two statements to be logically equivalent. Then we're going to show some logical equivalence in an example. So I want you to recall some of the activities that we did for last time. You may remember that a lot of the statements where we did the truth tables, they were grouped together. And we found out that some of them had the same truth table. So an example of that was the statement not P and Q and not P or not Q. They had the same truth tables, and that will imply that they are what we will call logically equivalent. So our definition of logical equivalence is we say that two statements are logically equivalent when they have the same truth tables. Another way of saying the same thing is that no matter what the truth values of the variables in the statements, either both statements are true or both statements are false. There is no situation in which one of the statements is true and the other is false. So let's look at two statements, P implies Q and not P or Q. These are statements that look very different, but it turns out they are logically equivalent. Let's see if we can figure out how that is true. So for P implies Q, remember that one is false precisely when P is true and Q is false. That's in that second row that you see. And then it's true otherwise. It's going to be a little bit more complicated for not P or Q. Right? So first of all, we want to fill in the truth values of P and Q in the same order that they were in the first one so that it's easier for us to compare the two truth tables. We're then going to want to figure out not P, which is not too bad. We just look in the column with P in it, and then wherever we see a T, we turn it into an F. Wherever we see an F, we turn that into a T. So instead of TTFF for not P, we get FFTT. And then for not P or Q, we look in those two columns right next to it. That is going to be true when at least one of those is true. So the only place, so that means it's only going to be false in that second row where both statements are false. So we get false in the second row, true everywhere else. And notice that the true and false values match up perfectly between those two statements, which means they are logically equivalent. All right, so now I think you're ready for the activities. The name of the PDF is called Logical Equivalence.